Oh yeah, just like 30 seconds after putting them in the hot Dutch oven, we are cooking good. I will stir it from time to time to make sure everything gets in touch with the hot Dutch oven and everything gets in touch with the air and all the plastic burns off and ashes up nicely. Well, hello scrappers, Mike here. Welcome back to my channel. And today we're going to tackle some unfinished business in the form of a whole bunch of tantalum capacitors right here. Got a bunch of them here. I did less than half of the tantalum capacitors I had in the last video I did on this, which I'll put a link to in the upper right. And well, I was a little dissatisfied with the final result. Me and my buddy Jim, we were talking about this the other day, and we both think I lost some silver somewhere. That there should have been a lot more silver there at the end. And even though I had less trouble processing these than the first time I processed it, it seemed to go a whole lot smoother. There could have been a couple places where I lost some silver. So we're going to revisit this, and we're going to see if we can find the missing silver, number one. And number two, we're going to incorporate some ideas I had during the processing the first time around to make it easier, less expensive in nitric acid, and less messy, because the nitric acid produced a whole lot of very fine rust, iron oxide, which may have been where some of the silver went away. It may have gotten trapped in that thick, gloopy, rusty, diarrhea-like stuff that was created. Sorry for the language there, but there's no other good way to describe it. If you saw the video, you know what I'm talking about. And some cement silver may have gotten incorporated into that and washed out of the mix during the process. So we're going to try a couple of different things this time and see if we can do a little better. All right, so I want to do better this time around. So what are my criteria for this working better? Well, number one, got to use a whole lot less nitric acid than I did the first time around. Nitric acid is expensive if you buy it and laborious to make. I usually make it, and it takes a lot of setup time, and yeah, okay, it's laborious. And I want to use a lot less of it this time around. Number two, I want it to be a lot less messy. We had what I call rust diarrhea in this stuff, which made the stuff really thick and gloopy and could have caused some of the silver loss if silver was indeed lost. So don't want to have that rust diarrhea again. Number three, a better silver yield. Got right around 1% last time, which I thought was kind of low. My buddy Jim thinks it's kind of low, and I agree. So this time I'd like to see a higher yield. Now it's a little bit apples and oranges because it's not the exact same mix of tantalum capacitors here. Last time it was about 50-50 black and yellow with some other colors mixed in. This time it's almost all yellow with 10 to 20% black and nothing else. So I won't I wouldn't expect exactly identical results, but if I do significantly better than 1%, I'll call that a win. So those are my three main criteria for how I'm going to judge this as working better. You guys had some good ideas in the comments. Maybe I should use muriatic acid up front to digest the iron instead of nitric acid, and that's not a bad idea. That will produce soluble iron compounds. I won't have that nasty, rusty precipitate. And I got to thinking myself that I could try sulfuric acid. And that might get rid of the iron. Again, make nice soluble iron compounds, no rusty precipitate. So what I might do is split this into two different batches and try it both ways and see which works better. Um, so first thing we need to do is weigh this up and then go through all the other steps to get to the point of where we're ready to process this stuff. So let me get my scale, we'll weigh it up and see how many tantalum capacitors we got left to process here. All right, let's see what we got here. 5.305 pounds. Oh, there's more of them here than I thought. Or 2408 grams. Yeah, so little over 2 kilos left. So we got a lot of tantalum capacitors here. So I think there's enough that I can split it into 2 batches and try running it both ways. Do the initial acid extraction to get rid of the steel in here, which is basically iron, with 2 different types of acid, hydrochloric and sulfuric. I think I will do that. But before we get to that step, we've got to go through all the other steps to get there. So I've got to incinerate these. I've got to crush them in my ball mill. I've got to do a gravity separation. Now, the gravity separation, I'm going to do a little bit different too, because that's something else me and my buddy Jim were talking about, where I could have lost a little bit of silver, although I really don't think I lost much there, if at all. But we're going to do a little bit more careful with the gravity separation anyway, just to make sure I don't lose any silver. And then we'll be able to get what's left after that into 2 big beakers in the fume hood, and we'll treat it with 2 different acids and see what process works better. We'll get rid of all this iron and steel in here, nickel, and then we'll switch over to either nitric acid or poor man's nitric, which I might do one half one way and the other half the other way, and get rid of the copper in here, and then we start dissolving the silver and recover the silver. So, all right, got my work cut out for me. I won't belabor this. If you want to see the incineration and the crushing in detail, click on the link in the upper right and watch the previous video how I did it. I'll just go through this really quick. We'll get these incinerated, we'll get them crushed, we'll start the gravity separation, then we'll move on from there. All right, we got the same setup as last time. Got my Dutch oven over the top of my foundry furnace. Got some fire brick around it to direct the heat onto the Dutch oven. This is already hot. It's been running for a few minutes. I find that there's a whole lot less smoke if I do this with a preheated Dutch oven. So, just like last time, I'm gonna load it up. With capacitors. I'm going to put my screen over the top of it because they do tend to be a little popcorny. They will fly out as they heat up. So we'll just let this cook. Like I said, if you want to see this process in detail, check out the last video. The link should still be in the upper right. Oh yeah, just like 30 seconds after putting them in the hot Dutch oven, we are cooking good. I will stir it from time to time to make sure everything gets in touch with the hot Dutch oven and everything gets in touch with the air and all the plastic burns off and ashes up nicely. All right, first batch is done. That Dutch oven is red hot, but that's good. Ready for another batch. So while it's good and hot, I'll put another batch in. Get them started. And just keep this up until they're all well cooked. Looks like I got maybe one more batch after this. Put this on before they start popcorning, and we'll be done in no time. Flaming already. Goes quick when the Dutch oven's already hot. And just like I did last time, I'm going to take the incinerated, now cool, tantalum capacitors, and I'm going to load them into my home-built ball mill, which is an inexpensive vibratory tumbler filled with 20-some pounds of various size ball bearings. Easy peasy. And this is going to crush this stuff up pretty darn well. So we'll get this started. I found out last time that running this for 2 hours with a load of incinerated tantalum capacitors in it does a pretty good job of crushing them into a fine powder. So here we go for 2 hours. All right, so this has had 2 hours in the ball mill. So those tantalum capacitor remains after incineration should be a fine powder for the most part. There will be some lumps of tantalum in there. If the way I did it last time is any indication, we'll have that. Now, speaking of last time, we're going to do this exactly like last time. I've got my shop vac way there in the back that's going to be pulling a vacuum on my dust deputy here. I'm going to vacuum the dust out of the ball mill. It's going to go through the dust deputy cyclone here. And the dust, the lumps, whatnot, are going to drop into this bin. And mostly clean air is going to go back to the shop vac. So that's the way this works. So I have found that vacuuming this stuff out while the ball mill is running works best, because the powder in there is thrown up the sides of the ball mill by the vibration of the balls jumping up and down in there, and that makes it easy to vacuum out. So let me get it vacuumed out, and we'll get another load in there running. Okay, I put gloves on because this is going to be messy. Probably full of a lot of black powder here. Get this lid off. Oh yeah, lots of black powder. Okay, so I'm going to start up the vacuum, then I'm going to start up the ball mill, and I will vacuum out all of the remains. All right, that's nice and clean. Let me get another three handfuls of incinerated tantalum capacitors in there, and we'll get this started for another 2-hour run. 3 is about as much as I want to put in there. Just like last time, that last handful was a little light, so we'll put a third little bit more in. All right, we'll get the lid on, and we'll start this up for another 2 hours. And we will just keep this up until all of these tantalum capacitors have been through here, and they are all a powder in the bottom of that dust deputy bin. And then we can go on to further processing. Here we go. All right, that's all the tantalum capacitors processed through the ball mill. All the dust is in here in this canister now. So next step is I just need to dump the dust out of this canister into a 5-gallon bucket, and we can move on to gravity separation. Up till now, I've done everything exactly like the first time around. With gravity separation, things are going to change a little bit. Going to try and improve the process. So I will meet you over at the other end of the yard where I do gravity separation after I get this stuff into a 5-gallon bucket and show you what we're going to do different. All right, so up till now, we've done everything just like last time. Starting here, we're going to do things a little bit differently. Going to try and be a little more careful, put in a little more forethought and deliberation, and be a little more patient with how I do things, okay? Got my bucket of black powder. We're gonna do just like before. We're gonna get it wet. We're gonna stir it up, and we're gonna let it settle. Then put some jet dry in to break up the surface tension so nothing floats. And then we'll pour it off gently to try and get rid of the black ashy stuff and leave behind the metal in the bucket. But I'm going to do things a little different, especially the first few times I do this, because it's going to have to happen a few times to get rid of all this black ashy stuff. And the first few times, there's so much ash in here that we're going to have a really thick slurry, and the metal is going to take a while to settle through that slurry. So I don't want to pour it off too quick. I want to be patient. I want to give the metal a chance to settle. So I think what I'm going to do is, at least for the first few times, every time I stir it up, I'm just going to leave it sit for 5 minutes before I do anything to it. Then I will gently pour off the liquid and just repeat. Get some water in here, get it good and wet. I'll fill the bucket maybe up about halfway, maybe not quite that far. Wash the powder down off the sides. That's probably about enough. There's a sheen of oil on the surface. I'll give you a look at that with my phone. That sheen of oil on there, that is probably pyrolysis oil from incomplete combustion of the tantalum capacitors. Turn some of the plastic into oil. This is where jet dry comes in. Look at that. This is going to break up the surface tension of the water and prevent any metal from floating. The oil will tend to coat the metal particles and cause them to float. The jet dry is going to help prevent that. Okay, let me stir this stuff up now. Okay, we're going to give it a good stir. Make sure everything's good and wet. There's no dry powder down there. Everything up in the water column. Okay. All right. So now everything's up in the water column. I'm just going to let this sit for about 5 minutes. Hopefully, the metal will settle to the bottom. A lot of the really fine ashy stuff will stay in the water column. And when I pour it off, it'll go away. All right, so see you in 5 minutes. All right, it's been 5 minutes. So let me gently pour this stuff off. Oh, wow, look how clear the liquid is. Maybe I didn't need to wait a full 5 minutes. Because it looks like a lot of the black stuff has settled out. So I'm pouring this into another tub here. This other tub will catch any solids that come over that I don't really want to lose. And don't worry about the grass, okay? It's just dirty water going into the grass. Been doing this forever. The grass doesn't seem to care. Okay, so let me put in some more water. You might be asking yourself, why am I going to all this trouble? Why don't I just treat all of the solids in here? Well, there's too much material here for any of my beakers. I could divide it up amongst multiple beakers, but still there's a lot of material here and only so much space in my fume hood and only so many hot plates. So I'm going to do it this way. Another problem is all this ashy stuff, this fine ashy stuff, is going to plug my filters. So that's a problem. So I'm going to try and get rid of as much of the really fine ashy stuff as I can, hopefully without getting rid of any of the silver. Okay, that looks pretty good. Got another little sheen of oil there, not as bad as last time, but there's some. In goes the jet dry. And we're going to stir it up again. All right, so just for the sake of consistency, I'm going to wait another 5 minutes, although I think it's a little long in this case. And then we'll see. Maybe I'll start cutting it back to 3 minutes after this time. All right, it's been pretty close to 5 minutes. Let's dump this off again. See how it looks. I could hear the solids in the bottom of the bucket slide as I tipped it over. There's a lot of heavy solids in the bottom of this bucket. And hopefully that's where they're going to stay. Okay, I'm going to stop there because I can't really see where the lighter solids are starting to come over because the water's still too black. So we're going to put in some jet dry at least one more time. I don't see any oil in there, but we're going to put some jet dry in. We're going to do this again, and I think from here on out, I'm only going to wait a couple minutes and then pour it off because that liquid coming out is pretty darn clear. So I think this stuff is settling pretty fast. But I'm certainly going to wait a couple of minutes anyway, just to be sure that I don't bring any solids over. Give it a chance to settle. And I'm just going to keep this up until basically all I'm getting out of this bucket is clean water. Then we'll look and see if we brought anything over into that pan that needs to go back in the blue bucket. But first, I got to do this 5 or 6 more times. You don't have to watch the whole thing. You're getting the idea. But I'm going to dump it off a little quicker this next time. I don't think I need to wait the full 5 minutes. This stuff's settling pretty quick. All right, I've rinsed this stuff a few more times. Now, normally I would keep this up until the water is coming off clearer than this, but I can see into the water a little bit. So it has clarified a lot. I can see the edge of the bucket. I can see there's no big solids coming over. So I would say this is going to be good enough for now. I'm going to stop a little earlier than I normally would, just so I don't risk bringing over any of the good stuff. So the water's not quite as clear as I would like. I will risk clogged filters, but there's all our stuff in there. It's left over after all this washing. Hope you can see it. So, all right. Now it's time to see what we've got in here. I'm going to do the same thing. Pour this off into another container and let it overflow. And we'll see what's on the bottom of this one. Not much. Just a little bit of very fine slime in there. But I'm going to wash it. A couple of times. And anything that stays in, I'll let it settle too. Anything that stays in, I'll put back in the blue bucket. Now there is some slime that's staying there after that washing. So it's obviously got some heavier stuff in it. And let it settle. I mean, I'd be very surprised if I didn't bring some heavy stuff over. Yeah, that water's clarifying fast. May not look like it on the camera, but it's pretty clear. Yeah, there's just a tiny amount of stuff here. I'm not even going to continue with that. I'm just going to put it right back in the blue bucket. All right. There we go. Let's see what's in here. Probably nothing of any consequence. Some very, very fine slime, which I'm not even going to put back in the blue bucket because I doubt there's any metal in that. If there is, it's not even going to move my scale. And that stuff's so fine, it's just going to clog my filters. All right. So let's get over to the fume hood with this stuff and get on with business. All right, time to get this stuff out of this bucket and into one of my big beakers here. Now, I'm not quite sure how I want to process this stuff from here on out. I don't know whether I want to... I used nitric acid last time. I went right straight to poor man's nitric on this stuff, and I think that was a mistake because the iron in here got converted into very fine rust, and I think I might have lost some cement silver decanting off that rust because it's turned into like pudding. So I don't know what I want to do with it. I'm going to run an experiment and see whether I can pre-treat this stuff with either sulfuric acid or hydrochloric acid to get rid of the iron out of it before I go to poor man's nitric or straight nitric acid, one or the other. So depending on what I do next, I don't know if I want chlorine in here or not. So I'm gonna wash this stuff out of here with distilled water. You know, the gravity separation was done with tap water, but I might not want chlorine in here going down the road. So I'm going to use distilled water here to get this stuff out of here. And I'll rinse it a couple of times with distilled water. If I decide hydrochloric acid works better, then this was probably a waste of time, but oh well. It's not too big a waste. That's a pretty clean bucket right there. Okay. Now it's a pretty clean bucket. Okay. So I'm going to rinse this with distilled water a couple times. And I'll give you a look at it before we move on. So here's a look at the stuff down in the bottom of the beaker. It's not as colorful on the video as it is to my eye. It looks really coppery. And last time I did this, I got a lot of copper out of this stuff. So, yeah, I can see the copper in there again, but we've gotten rid of a whole lot of other stuff there. Got rid of all that ash. All right, I think I'm going to run an experiment. I'll show you what I'm talking about here in a minute, once I get it started. So I'm trying an experiment to see how I want to process this stuff from here on out. Now last time I just went to poor man's nitric acid right after the gravity separation. And all that nitric acid created a whole lot of very, very fine rust in the liquid as it attacked the iron in this stuff. And I think I might have lost some silver in amongst that iron as I tried to decant it off. So what I've got going on here is two beakers with roughly equal amounts of the material in them. And this one has hydrochloric acid on it, and this one has sulfuric acid on it. And I'm trying to figure out which one is going to do a better job of dissolving the iron out of there. Now both of them should leave the silver alone. Certainly the hydrochloric acid will leave the silver alone. It'll get passivated with a coating of silver chloride, and that'll be the end of it. Now to my eye, the sulfuric acid has been reacting a lot stronger than the hydrochloric. So, decisions. Now there is some reaction with the hydrochloric though, especially as they both heat up on the hot plate here. Adding the sulfuric acid to this causes it to heat up immediately, whereas this has needed time to heat up. Well, anyway, I'm just going to let them go for a little while and try and gauge which one's doing a better job. Alright, after letting these go for about another hour, well, it's a little inconclusive about which I think is working better. Certainly there's more fuming off of the hydrochloric acid one, but that really doesn't tell me much about how fast the metal's dissolving. And there's actually fairly vigorous bubbling in both of them on pretty low heat. This is not hot at all, not like boiling or anything. So I think what I'm going to do is I'm just going to let these sit overnight, take a look at them in the morning since it's getting pretty late out here, and make a decision then. Because really at the moment it's just as clear as mud which of these I want to use. Alright, so it's been almost 24 hours. And I've got my two samples here. This one was hydrochloric acid. This one's sulfuric acid. Um, all right, so some observations. This one seems to be done. I don't see any more activity in here. This one's still bubbling. So obviously it has not consumed all of the iron in there yet, even after 24 hours. So this one's still going. Um, so I was kind of leaning towards the hydrochloric acid even before figuring out here that it does it quicker. Just because I've got a lot of this on hand and it's pretty cheap. But there is another consideration that we need to think about. And that is, do we have any silver going into solution? So we're going to run a test here. I've got some liquid over here, some tap water with a little bit of muriatic acid in it. And I know that silver sulfate is slightly soluble in water. So it's possible that we're dissolving some silver here. Although since the iron has not all gone into solution apparently, we may not have any significant amount of silver in solution yet because it'll just, cement right back out on the iron in there, steel. But we'll check it here. Let me get some of this liquid. A little more than that. There we go. And see if we make any kind of a white cloud in here. Not really. It's very slightly turbid, but that might just be the liquid in here is slightly turbid, so I don't know. And also I want to test this stuff because silver chloride can go into solution in highly acidic environments. So it's possible this might be holding some silver chloride in it. Now, this is very strong acid here, but this is very weak over here. As the pH rises when I put it in here, the silver chloride ought to come out of solution if we're carrying any. So let me put that in there and see if our turbidity is any worse. No, it's not. Okay, so I would say that neither of these is carrying any significant or even detectable amount of our silver. So there's really no difference between them at this point, although if I let this go to completion, it might dissolve some silver. But I don't think I'm going to have that problem because I think I'm going to go with the hydrochloric acid, muriatic acid, whatever you want to call it, because I think it's going to do the job quicker. It's cheaper. I've got a lot of it, and I can give the stuff multiple treatments to make sure I get rid of all the iron and any other base metals present that will dissolve in it. So, yeah, okay. I think we're going with that. So let's get to treating the bulk of the material here. So I've got the bulk of our material back in the fume hood. Let me wash this stuff into it. There we go. Okay, so now we don't have to worry about screwing up our yield calculation. Get the fume hood going. And we're going to give this a treatment with hydrochloric acid. Put in, what is that? That's almost a liter of hydrochloric acid. A good stir here. Get it all distributed. Okay. Alright, so let me put a lid on it, keep the heat in and reflux it a little bit, put some heat to it. I don't want to boil it too hard, but I know that heat's going to help because it's really cold out here. It's winter, even in Florida it's cold. So we'll get this going and see how long it takes. I can give it multiple treatments because I've got just a ton of this stuff. So We give it multiple treatments until it looks like we've got all of the iron out of it. And anything else will dissolve in muriatic acid. So, okay, we'll just let this cook for a little while and see what happens. Well, this has had a chance to warm up, and we are cooking good. A lot of bubbling going on. Not hot enough to boil, so that's just the acid reacting with the metal in there. Those are hydrogen gas bubbles coming off. So we are dissolving base metal. Excellent. I'm going to keep this up until the reaction stops, and then probably decant off this liquid and give it another treatment, just to make sure we get as much of the iron, steel, zinc, anything else that might be in there, tin, off of these things before we move on to the next step. All right, so it's the next day. I let this run until the end of the day and then shut it down and let it cool down. So this has had a chance to cool down. I'm going to pour off this first bunch of hydrochloric acid, and we'll give it a second treatment. Now, the observant among you, and some of you are very observant because you call me on this sort of thing all the time. It's just the observant among you will notice that there's more liquid in here than there was before. That's because off camera, I was busy with something else and didn't feel like setting up the camera and recording it. The reaction started slowing down at one point yesterday, so I put some more hydrochloric acid on it just to keep good times rolling. So we're up to about 1,200 milliliters of acid on there. So that's why there's a little more liquid here than there was yesterday when we started out. I think it was also evaporating down some, so I freshened it up a bit with some more. Okay, so let's dump this stuff off. Green. Ferrous chloride. Ferrous chloride green is what we got going on here. But that's good. That's a lot of iron leaving here. Excellent. And I can tell that we got rid of a lot of iron because this stuff looks even more coppery than it did before. So the copper is really starting to show through there. But I'm going to give it at least one more treatment just to be sure we get the bulk of the iron out of here before we move on to nitric acid. Or probably poor man's nitric acid to start with, I'm thinking. Then nitric acid at the end. Okay, so let me get this back in the fume hood and we will go again. All right, so let me get the fume hood going here. And get some more hydrochloric acid on it. All right. Put some heat to it again. Not too much. And we'll just let this cook for the next few hours at least, or until it looks like there's no more reaction going on. I'm not seeing a lot now as it's cold, so that leads me to believe that we may have already got the bulk of the iron in solution, although we'll see what it looks like when it warms up a bit. It may just be playing possum and fooling me in there. I'll give you a look at it once it warms up, and we'll see if I'm right or wrong. Well, I guess this stuff was just cold. Now that it's warmed up, we got a heck of a reaction going on, but yeah, it's nowhere near hot enough to boil, so that's just more hydrogen gas coming out as the acid's reacting with the base metals in there. Okay, we'll just let it continue to cook. It can do that all day long if it wants to. And get rid of all that nasty steel in there. So, be back when it looks like it's done. Well, this took a whole lot more time and acid than I thought it would. And I'm not 100% certain it's done. This is its third treatment. And this time I've just added some more acid to it a couple of times. It's been on here for days. I've been too busy to deal with it. I'll come out and turn the heat on when I think about it. And add a little acid to it. It's still got a little bit of bubble into it, but it's nothing like it was in the beginning. So I'm thinking the vast bulk of the iron has been eaten up by the acid. Probably not all of it. I imagine there's still some in there. But I think we're going to call a halt to this experiment just because it's been going on for so long. And I'm going to have some time to work on this. I think I'm going to let this go the rest of this afternoon and leave it overnight. And tomorrow I'm going to decant off this liquid and we'll pick up back in the fume hood after I've decanted off this liquid, and we will start treating this with other stuff. I'll probably also give the stuff a few rinses with distilled water to get the iron compounds out of it and the chlorine out of it, because we're looking for silver here. I don't want to convert it to silver chloride yet. So I'll give it a few rinses. So once it's free of the iron and the chlorine, we'll come back in here and we will start giving it some nitrate treatments and see if we can dissolve the silver out of this stuff. I thought I'd give you a look at just how coppery this stuff looks before I get it in the fume hood and start treating it with acid. It's definitely a whole lot more coppery looking than it was. I think we have dissolved away the vast bulk of the steel out of here. I can't pick the stuff up with a magnet anymore either. I'm not foolish enough to believe we got all the iron out of it, but I think we've got the vast bulk of the iron out of it, which is great. Getting a lot of black powder out of it too, which I think is probably very, very fine grains of carbon from the steel that's been dissolved. Steel is really an alloy of iron and carbon with, other trace metals thrown in. So I'll bet all this black powder is just carbon that dissolved out of the steel. Okay, let's get this in the fume hood and start dissolving away the other metals in here. It looks like we've got a fair amount of copper to get rid of. I know how to do that. All right, so that went pretty well. And I think it's time to go after the silver in this stuff. I think the first thing I'll do is treat it with poor man's nitric acid, and then maybe once we get all of the base metals in solution, we'll switch to regular nitric acid. But I think that's going to have to be in the next installment of this series, because next few days at work are going to be very long and busy. Holidays are coming up. I'm going to be busy during the holidays, so this is going to sit here for a little while until I can do anything else with it. We will pick up right here with this material in the next installment in this series and see if we can get the silver out. So, thanks for watching. I really appreciate it. If you found this video at all interesting, educational, informative, inspirational, whatever, give it a like, give it a thumbs up. Subscribe to see the next videos in this series and all the other videos I put out. And I will see you in the next video. Thanks a lot for watching this one. Bye.